Hey folks, so in this video I want to introduce the idea of the common methods in Java. Now these are something you've probably already seen before, but we're going to be spending some time on them in this class, and they'll mean a lot more to us too. So as kind of some review here of basic Java, one feature we have is this idea of inheritance, right? And so inheritance is basically saying, oh, I have classes, right, that maybe inherit from other classes. And in Java, basically you don't really have a choice. Inheritance happens behind the scenes. Now when two objects basically have this inheritance relationship, you generally have this thing called like a parent and this thing called a child, and the child takes on all the behaviors that the parent has. Now, why am I talking about this? I'm talking about this because in Java, all the different objects that we create are automatically going to be, or all the different classes we're going to create are automatically going to be subclasses of another kind of master class, right? Which is called object. So in my system, right, there's something called object. And even though I didn't say anything in my code, the classes we create, right, so even something like, counter, counter is actually a child of object. And that means that all the different behaviors that are associated with object are going to be naturally become part of that child. They're going to become part of counter. And so this leads to what I call the common methods in Java. So this is basically, a set of methods that every single class and object will have because they all descend from this object, master class in our system. So what are those methods? The ones that we care about are the ones that are on the screen here. So we care about equals, hash code, and toString. So these right here are kind of these methods, right? So these basically everything's going to come with an implementation of them already. Well, they're going to have gotten some code right from their parent that says, oh, this is what these are, this is how they work. Most likely you've seen these functions mentioned at one time or another. Now, by default, we get some sort of implementation from our parent that basically the parent's like, oh, this is how things are. But we also have the ability to override them, right? And this is actually a keyword in Java. So you've seen maybe in Java, you'll see source code that has like an @ symbol, right, and then the word override. What that's actually showing you is that your class has a method in it, and that method needs to replace something that the parent had, right? Because maybe the parent already had an implementation of this thing, right? Already defined this behavior, and we decide that we as a child, right, we can do a better job at it, right? We can do something else a little bit different, and so we override what they give us. And so by default, right, we basically get these three implementations, or these three functions, right? We get an implementation for them from the parent class, and then we can update them if we want. Now, a lot of times in what code you've written so far, you probably just left these things alone, right? Equals, hash code, toString. Well, toString probably you've had to implement a few times. It's something that's very typical in debugging. So yeah, let's actually talk through these, right? What do these do? So equals. Equals is a method that basically lets me compare two things. So it's like, well, I have class A, or I have object B. Are they the same? Are they different? Well, to do that, right, I use equals, right? So equals is something where I do like A.equals of B, right? And that's an expression that can basically tell me, are these two things the same or not? Now, of course, right, this is something we probably want to override when we build our classes because our sense of equality probably depends strongly on the particular classes. So it's like, well, if I have a car, I need to make sure that cars A and B are equal if they are the same color, if they have the same wheels, right? I need to compare things specific to the object. So that's something we should look at implementing. Now, hash code is another thing you probably will have, well, probably won't have implemented. I'd be very surprised if you implemented already. But you may have seen in terms of warnings in your IDE. So sometimes when people go and implement equals, what happens is their IDE complains is, hey, missing implementation for hash code, blah, 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 contract error, blah, 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 right? And there's all this, error messages to print out. And basically what it is it's insisting that you, implement hash code at the same time you implement equals. So what does hash code do? Why is it related? Hash code is basically a unique identifier or a unique number for an object. So it's like a special number that basically identifies that object. And so the idea is, right, if as an alternative to the equals, right, basically what I can do is I can have two objects, A and B, and I can check the hash code on one and compare it to the hash code on the other. If the hash code is the same, that implies the objects are the same. They're equal to one another. Okay, so that's kind of what the IDE is complaining about, because it's like, well, if two objects are equal in terms of equals, they should also be equal in terms of their hash codes being the same. Okay, so that's what it complains. Because normally hash code, it's got like some other implementation that won't match up if you customize your equals implementation. So yeah. Last one here is toString, which you guys have used before. Basically, it's how do I print out stuff, right? I need to get some sort of string representation of this object. That way I can print it on the screen. That way I can debug it. I can figure out what's going on. Very, very typical. As a quick example here of these default functions or these default implementations, I could do something like, for example, create a class of point2D, right, to represent an XY point on a plane. Well, by default, if I don't do anything, right, with these methods, right, I basically get the implementation that my parent provides, but my parent doesn't know about what I want, so it just does its own thing. And the implementation it provides is very generic. So here in this example, right, so I have, without toString, if I were to print out my point2D class, I just get the name of the class and then some random numbers after it, which are probably something like an address. Not very useful to me, but really we couldn't expect anything more, because if we were using the implementation of toString from our parent didn't know what we value, right, and probably value X and Y. So us, right, our job is basically to implement toString, right, and give it some more, use, right. And so in this case, what I can imagine, I do an override of it, and I make it print out the X, Y values, right, in parentheses, right, in that proper, point notation. And so then I get this over here. So this is way nicer, right? So this is typically what we end up doing, right? Is we have to override these things, right? Even though there is some sort of default implementation from our parent, we need to override them and actually make them useful for us, right? By making them more specific to the data that we contain, right? Or the state that we contain. All right, so hopefully you guys have a kind of a, jog some memories there, right? You guys should know, right? Equals, hashcode, toString, what are they, right? Why we want to implement them.